All right. Am I on? I'm on. Excellent. Last talk of the day, everybody. All right. We're finally here. All right, my slides are up. Everything's good to go. This is going to be great. Hi, I'm Jeremy Elbourn. I work at Google, and I'm a member of the Angular team, and I primarily work on the Angular material components. If you are unfamiliar with Angular material, it's a library of reusable directives and services in Google's material design style that's provided by the Angular team. You can hear more about that from another talk by Thomas Burleson tomorrow. But here's just a quick shot of our website so you can get an idea of kind of what we do. There's some buttons on there, other components. You get the idea. And what I'm going to be talking about today is building the best components, building really good components, really building the best components ever. And I'm going to start this talk off by first mentioning that this is focused on Angular 2, and then posing a question. And that question is, what makes a good component? And we've thought about this a lot as we've worked on Angular material, especially as we've gone into planning for Angular material in Angular 2. How do we measure the technical quality of a reusable Angular component? And to that end, we've put together a checklist for everything that needs to be done in order for a component to be called complete. Now, obviously, no piece of software is ever totally done, but this state of completion tells of something that has all of its parts without any obvious gaping holes. And here's the checklist. And nothing on here should be a major surprise. You have a simple API, works across browsers, accessible, internationalized, well-documented, robust tests, you're measuring performance. We're still fine-tuning exactly what these criteria are, but we'd love to see this checklist, or something like it, become a widely accepted gold standard for evaluating components. So are you all ready to spend the next 3 hours on a complete deep dive into all of these topics? Yeah, great. Unfortunately, we only have 25 minutes, and we can't cover all of these topics in a lot of depth, so we're just going to go through some of the highlights. And these highlights are going to happen in two halves. First, we're going to talk about your components on the outside, which gets into how both other developers and end users interact with your components, and your components on the outside, which gets into some best practices and code health advice. So, your component on the outside. The most obvious thing to talk about in this context is the public API of your component. So in Angular 1, the vast majority of public APIs were done via attributes which you use to bind data and set expressions that get run on events. In Angular 2, this is very much still the case, and it's even better than ever because the new templating syntax is so much more explicit and powerful. But there is more API surface area to explore now. So one such area is the component class itself, which is analogous to the controller in Angular 1. So in Angular 1, controllers were not commonly exposed to consumers. Instead, they usually contain your own private implementation details. This is changing in Angular 2, where it's much easier to get a reference to a component instance both in your template and in component code. So let's take a look at an example. So here we have an Angular 2 template, and you've probably seen the syntax already today. If you haven't, it's pretty simple. The hash vid syntax defines a variable called vid and assigns to it an instance of this cool video player component. And then we have a button that, when clicked, calls the play random video method on vid. And as you can tell, this opens up a lot of possibilities for method invocation on custom components, which wasn't really a thing in Angular 1. And it's not just template code either. Let's take a look at another example. Here we have a cool tab group component that is going to contain some children tabs in its content. Angular has a parameter decorator, this at content children that you can see here on the slides, that you can use to get a reference to each of those tab instances and directly access properties and call methods on them. And this also works the other way around. Here we have a tab component, and it can use the @host parameter decorator in order to get a reference to the parent tab group and interact with it the same way. Because Angular 2 makes it so easy to get a hold of component instances with APIs similar to this, you'll find that more users will want to interact with your components in this way, and that the public API on the be very important. Now, another thing worth mentioning is that the events fired by your component are also a part of its public API, and you're going to see more use of events to communicate data changes due to the way that change detection now functions in Angular 2. You might have seen Brad mention in the keynote that Angular 2 now has a unidirectional change detection, which makes it simpler and cuts out some of the confusion you might get with the arbitrary two-way binding between any 2 points in your application. Unfortunately, all the events that can be fired on a component are declared up front, which makes it easy to check, both by reading the source and by tooling exactly which events a component can fire. So looking at an example, here's a component which defines 2 events, selected and deselected. Both are defined as part of the component class definition. This is much more explicit than in Angular 1, where you could fire any arbitrary string as an event at any time. The takeaway here is that the component properties, methods, and events are all equally important parts of a component's API, and it's key to consciously decide what is and isn't part of your public API, and then to make those APIs as simple as possible. It's also worth mentioning that those of us on the Angular team still have limited experience building stuff with Angular 2, and so we have a lot more to learn about API design best practices as the framework matures. So public API is very developer-focused, so let's talk about something a little more user-focused, accessibility. This is making sure that your components are usable by a widest variety of people as possible of all different abilities. So let's take a look at some of the things you can do for accessibility in Angular 2. Now, the first piece of accessibility advice you always hear, no matter what the context is to use the right element for a given job. And this means that a button with a click is always better than a div with a click handler, because the button has more semantic meaning. The browser knows how to work with the button better. So Angular 2 lets you specify components via selector, which means you can always use the right element for accessibility purposes. In this example, we're using an attribute selector for cool button in order to take advantage of everything that the native button element gives us, including keyboard shortcuts, screen reader support, and interaction with form elements. If we were to use an element selector and create our own tag called cool button here, we would lose all of that. Now, using native elements is good, but sometimes it's not enough, and you have to mark up your template with ARIA attributes in order to tell some screen readers how to present content for vision-impaired users. With Angular 2, you can set up bindings on ARIA attributes in the same way that we've seen for properties like value and disabled. The only small difference is that for ARIA attributes, you do have to use this extra prefix, attr dot, as you can see in this example. This is because, by default, Angular 2 binds to properties, but the ARIA spec is implemented through element attributes instead of element properties. So this illustrates how you can do ARIA binding in your template, but it's not really how we would build a custom checkbox component, is it? For that, we would want to make a component. So let's look at that. Here we have a checkbox component, and we want to set the appropriate role and ARIA check state on the element that represents the whole thing, the host element. We can do this by using the host property in the component configuration, which supports the same syntax as the template we just saw. Host bindings let you set properties and attributes on that host element without having to tediously set up watchers and manually update the element like you would have done in Angular 1. And you can either set up host attributes and properties like this in the configuration, or you can do it via a property decorator called host binding, which does the same thing. So using the correct elements and setting up ARIA attributes, these are good, but it takes more than that to create a really good user experience. Keyboard interaction is incredibly important for both vision-impaired users or users that have a hard time using a mouse, or people who just don't like to take their hands off the keyboard. Angular 2 gives you an extremely convenient shortcut for setting up keyboard interaction. This may seem really minor, but I'm actually really excited about it because of how clean of code it leads to. In this example, we're setting a key down handler for the space key to toggle a checkbox. Angular understands this keydown.space as an event and will only fire the handler when there is a keydown event for the space key. And of course, you can use multiple of these event bindings at once. So on a single element, you can say you have a binding on a single key, like keydown.u, or with a modifier key, like keydown.control.enter, or with multiple modifiers, like keydown.alt.shift.escape. This makes it really easy to cleanly handle a lot of your keyboard shortcuts, and no more do you have to live under the tyranny of the key code switch statement. One last thing to mention for accessibility is focus management. So for keyboard users, especially those using a screen reader, it's critical to manage the focus in your components. For example, if you were to open a modal dialog, you would want to make sure that the focus remains in that dialog even if the user hits tab a whole bunch of times. And we can accomplish this in this example by using a simple template variable and an event binding without having to add any code to the component class at all. So here you can see we have a dialog element that's assigned to the variable myDialog. And at the very end of the dialog, we have an element with tab index 0 that catches the focus when you tab into it, and has a focus event handler that sends it back up to the top of the dialog, so the focus wraps and keeps it inside of that dialog, which is really nice. So as you can see, building accessible components for Angular 2, Angular 2 makes it very possible. It's still hard work to actually do it. It's something you have to spend effort on. But Angular 2 doesn't get in your way and gives you some nice tools to make it a little bit easier. So API design and accessibility, that's pretty straightforward. You've heard of these things before. But now I want to talk about something that you may not have considered before, or at least in this light. So I'm sure at some point all of you have written a unit test that looks something like this. You want to call some method, check that a confirmation was shown, then click confirm and assert that the gated action actually took place. You end up having to do something weird or convoluted to actually click on the confirm button in your test. Because why would your dialog service have an API for saying confirm? In a live application, you would want that to be done by a user action. But in the test, we need to imitate that action. And here, there's a lot of moving parts, which can lead to the test becoming brittle and making your code harder to maintain. So how do we improve this? So here we have the same test that has been configured to use a fake dialog implementation. The fake dialog has the same methods as the real one, but also has some extra methods that help make testing easier. You can see fake dialog has a method to assert that the confirmation is open, and another for clicking OK on behalf of the user. Note that we're actually not testing the dialog itself here. It has its own unit test for that. We're just testing here something that depends on the dialog service, something that consumes it. If you're the one writing components or services that are going to be used by others, you can make testing much easier by creating fakes like this that you distribute along with your actual implementation. Now, when I say fakes, what am I actually talking about? So fakes are a testing tool where you create a drop-in replacement for something that exposes all of the public API of the real implementation, plus some additional properties and methods for unit test assertions. But that doesn't actually do anything other than track some simple state. So in the case of our dialog service, the fake would provide the same API for things like configuring and opening a dialog, but also provide methods for interacting with the open dialog, such as clicking OK, and for making assertions about the state, such as whether or not it's open. Writing a fake implementation can also help you think about your public API and help you refine it before you get to the final version of your component. And of course, making fakes makes testing applications that depend on your components much more pleasant. And when I talk about users using your components, it doesn't have to be some really popular open source project, even if it's just the other 3 people on your team who are using the component, or even if it's just you by yourself. Following this pattern can really help keep your test focused on testing exactly what it is you're trying to test without having to jump through any hoops from cross-component interactions. Now, implementing fakes is not a new concept in Angular. The core for Angular 1 comes with fake implementations of $timeout and HTTP backend and so on. And with dependency injection in Angular 1 and in Angular 2, you can easily create fakes for your own services. What's new in Angular 2, however, is that you can create a fake for an entire component. So let's look at an example to see what I mean. Here we have a cool menu component that has two dependencies, cool button and cool pop-up. Now let's look at cool pop-up. Say this is something that creates a floating element and it appends it to the document body and it absolutely positions it, and it does a cool animation when it opens with ng-animate, and for some reason it has a set timeout or two in there just because. You've probably had to deal with a component like this in Angular 1, and when you use it and write a test for something that's using it, you get stuck trying to figure out the magic order you need to call timeout.flush and animate.flush or other hoops you have to jump through in order to get it to work. This would be so much easier if the unit tests for cool menu didn't have to deal with this dependency leaking its implementation details. So we can accomplish this by using a fake implementation of cool pop-up instead. The fake pop-up component would look something like this. It implements the same API as the real cool pop-up, but the implementation doesn't do much, just tracks some internal state. One cool trick is that TypeScript actually lets you use the implements keyword on a class, not just an interface, if you want to say something should have the exact same public API, which is pretty cool. This is very straightforward to build, and once we have it, we can pretty easily configure our unit tests to use it. Angular 2 has this test utility called Test Component Builder for unit test. We're not going to talk about that much right now, but all we really care about looking at is this one method it has called override directive. And this calls pretty simple. It's just saying for cool menu, override the dependency for cool pop-up, and use fake pop-up instead. And that's it. This might end up being slightly more lines of code or more files than it would be if you used the real implementation, but in the end your code is going to be much simpler and easier to maintain in the long run. And that concludes my section on fakes. I thought it would be appropriate to wrap up with a fake slide about fakes. Thank you for your fake laughter. All right, so your component on the inside. Now that we've looked at it from the outside, start off by talking about some code health best practices. So we're going to talk about embracing different things in Angular. So embracing dependency injection, this is the same idea as in Angular 1. There's not a lot to talk about here because the idea for dependency injection has been around for about, 20 years. But Angular 2 does improve its DI system a bit. There's no more single global dependency injection namespace, no more coupling of dependency injection to modules, and Angular 2 generally gives you a much greater control in configuring which injectables are used where, which can help keep your app organized. So same great stuff you've come to like. Now, embracing the template is something that I'm sure all of you like about Angular 1, and again, it's more refined in Angular 2 with much more explicit templating syntax. In particular, it removes a lot of ambiguity from expressions where sometimes you don't know, is this a string literal, or is this expression, or is this an interpolation expression, and so on. And so the more you do with templates, the less code you end up having to write on top of DOM APIs, which can get tricky as they grow in complexity. So in the Angular 1 world, there were times when you had to break away from templating when facing really tough performance constraints, have to get down and do stuff on the DOM directly. But with the performance improvements in Angular 2, this should be a problem of the past. And one more cool thing is that new in Angular 2 is the concept of portability of your component code. By avoiding directly dealing with the DOM, you open up the door to new environments. Of particular note, this enables two things. The first is server-side rendering, which was the subject of a talk from Jeff Welpley and Patrick Stapleton earlier this morning. So if you didn't see that, watch the video. And the second is that this can enable your component to run in a separate web worker thread, as Brad hinted at this morning in the keynote. This is really exciting, and if you want to know more about that, be sure to check out the talk tomorrow by Jason Teplis that is going to go on that topic. And one last thing to embrace, as I'm sure you've heard enough of this today, is embracing types with TypeScript. This is something that really only applies if you have decided to dive into TypeScript, but TypeScript can give you, or types in general, can give you much greater confidence about your code with static analysis. It can make tooling easier, make it so that you get auto-completion and things like that. If you're writing TypeScript code, you can generate the widest set of APIs for consumers of your components. You can generate ES5, ES6, and TypeScript. It's more challenging to go the other way around. And Martin Probst and Alex Eagle will be going into more depth tomorrow in their talk about TypeScript. So be sure to check that out, as well as the talk from earlier this morning that was also about TypeScript. No discussion of code health would be complete unless we also talked about testing. Unit tests in Angular 2 are structurally the same as in Angular 1. There are new APIs for testing, however. Where in Angular 1 you would manually use the $compile service and link some templates in your unit tests, Angular 2 provides this tool called Test Component Builder that lets you easily spin up a test instance of your component. Using this is as simple as injecting the builder, as you can see in this example, and then calling a method on it to create a component instance. Very simple. When you use the builder, you get from it what you need to write a test. Don't worry about all this stuff. All you really care about is from this that you can get the component instance and the underlying DOM element, and then do whatever assertions it is you need to do on top of that. This testing utility can also do a little bit more, though, such as overriding providers, so you can inject fake services, or overriding directives, so you can insert fake components, or overriding templates, so that you can change the template from test to test. Note that these APIs aren't final, but they can give you some idea of the capabilities you'll be looking at. Julie Ralph gave a more in-depth talk on testing earlier today, so if you didn't catch that, be sure to check that out. I'll also very briefly mention end-to-end tests here. Looking at this simple example, you can see it's pretty identical to how things were in Angular 1. Here we have a radio button that is retrieved, it's clicked, and then you assert that it's checked. I won't go into much detail on this because 1, it's still pretty similar to Angular 1, and Protractor for Angular 2 is still in its early stages, and again, Julie talked more about that. But what I will go into a little more detail on is measuring performance. So you finished your code and it's super clean, you've got tests making sure it's working correctly, and it seems fast, but how do you prove it, and how do you make sure it stays that way? Well, you already have automated unit tests and end-to-end tests to guard against behavioral regressions, so the logical thing to do would be to have automated tests for performance. And this brings us to BenchPress, which is a framework used to create and run benchmarks in order to gather a bunch of different performance metrics. It was created by the Angular team to monitor the performance of both Angular 1 and Angular 2. The metrics it provides, when tracked over time, can tell you when a slowdown has been committed in the same way that you can tell by looking at your commit log who broke a test broke some feature that you just implemented last week. So creating a BenchPress test is actually really simple. So here's the simplest example of one that I could create. It's very similar to an end-to-end test. So first we create a new runner with some configuration and fetch our test page. Then we simply invoke the sample method on the runner, passing in our data for this test run. In this case, that data is just an ID for the run and the code we want to execute and measure. There are various knobs you can adjust with different configuration options, but overall, you can see that this is pretty straightforward. So what do you actually get out of these benchmarks? Well, as it turns out, you get a whole bunch of numbers. But these are actually very useful numbers. The output from BenchPress gives you things like the amount of garbage collected, garbage collection time, render time, script time, and several other metrics. With this output, you can track your code performance over time and know immediately when some change dramatically affects your speed, and you can also turn it into cool graphs that you can put on a big dashboard in your cube area, which looks really impressive when someone walks through. So that's a big plus. For a component that's going to be consumed by other people, having a test like this can not only prove that you care about speed, but gives users confidence that performance isn't going to degrade over time as you come out with new versions. And so putting this all together, what I really want the takeaway from this to be is that checking off everything on a list isn't a guarantee for quality, but it can really help highlight things that may fall through the cracks, and by following it, you can have yourself a formula that sets you up for success. So I highly recommend that you try it out on your own code. And that is it for me. Here are some resources and the links to these slides. Thank you.